A system of nonlinear equations is given. Sketch the graph of each equation and then determine the number of real solutions to solve the system. Do not solve the system. The system we're working with is x squared minus y equals -2 and 3x minus y equals -3. Now the reason we like to sketch a graph of a system is because it gives us an idea of what the solutions are. Usually the graphing method for solving a system is not the best way because we can only get approximate answers and how many solutions we have. So we prefer to solve these algebraically, but looking at the graph of a system will tell us how many solutions that system will have and the approximate value of those solutions. So as I look at this equation, I have x squared minus y equals -2. I know this is a quadratic equation. And the graph of a quadratic equation will be a parabola, a U-shaped graph. So I want to sketch a graph of this parabola. So I'm going to start by rewriting it. I'll rewrite x squared minus y equals -2. By solving for y, I'm going to subtract x squared. I have -y equals -x squared minus 2. And I'll divide each term by -1 to get y equals x squared plus 2. And now that I have it in this y equals form, I can choose some values for x and find the values of y. So I'm going to choose x equal to -1, 0, and 1. If I substitute in, I'll have -1 squared plus 2. -1 squared is 1, plus 2 is 3. 0 squared plus 2. 0 squared is 0, plus 2 is 2. And 1 squared plus 2. 1 squared is 1, plus 2 is 3. So this gives me 3 ordered pairs on the graph. I'll be able to sketch the graph with those ordered pairs. So let me get a grid on here for this example. We've got our coordinate plane here. I've got the ordered pairs 0, 2, 1, 3, and -1, 3. So that's the beginning of my parabola. If I want to get a little bit more of it, I can substitute in a 2. 2 squared plus 2, that's 4 plus 2, which is 6. So 2, 6. I'm also going to have -2, 6. I'm going to stop there for now, and I'm going to see where my other equation is. So my other equation is 3x minus y equals -3. This is a linear equation, and a linear equation you can graph by having just 2 points on the line. So I can let x equal 0 to find the y-intercept. That's 3 times 0 minus y equals -3. -y equals -3. And I'll divide by -1 to get y equals 3. I can let y equal 0 to find the x-intercept. And that will give 3x minus 0 equals -3. 3x equals -3. divide by 3 and get x equals -1. So for the second equation, we're going to plot the ordered pairs 0, 3 and -1, 0, 0, 3 and -1, 0. We'll connect those 2 points with a straight line. So you can see that we're going to have an intersection point right here. And it doesn't look like that intersection point is falling on a nice ordered pair. But you can see that the x-coordinate is in between -1 and 0, and the y-coordinate is in between 2 and 3. So we do have approximation for that ordered pair. But if we were going to continue our parabola, we also see that there's another intersection point over here. So this system is going to have two solutions, two ordered pair solutions for that system. The directions on this example say do not solve this system. So we're not going to algebraically find those solutions. But we can see from the picture that this system will have two solutions. A system of nonlinear equations is given. Sketch the graph of each equation and then determine the number of real solutions to the system. Do not solve the system. So once again, we are looking at a system of equations, x squared plus y squared equals 9, x plus y equals 2. And our goal is to draw a picture of these two equations. This is going to give us information about the number of solutions to this system and the approximate value of those solutions. Really, the best way to solve a system is using one of our algebraic techniques of the substitution method or the elimination method. So our goal here is just to get a visual representation of our solution to these system of equations. So this first equation, x squared plus y squared equals 9, is the equation of a circle. I know it's the equation of a circle because circles have the format of x minus h squared plus y minus k squared equals r squared. So the equation x squared plus y squared equals 9 fits into that format. HK is the center of the circle. And in our example, we don't have any numbers added or subtracted, so our center is 0, 0. And then you can see that r squared, r stands for the radius, and r squared is 9, and so we know that r is 3 for our example. So we're going to be able to draw the circle with this information. The second equation is a linear equation. So its graph is going to be a straight line. So we're going to have a circle and a straight line. And I know that's a linear equation because the equation is in the format, the general form, ax plus by equals c. So the key thing you're looking for a linear equation is both x and y raised to the first power. So to graph that linear equation, I'm going to find the slope-intercept form. There are many different ways to graph the line, but I'm going to find the slope-intercept form, x plus y equals 2. This is the standard form. Slope-intercept form is when you have y by itself. So I'm going to subtract x That gives y equals negative x plus 2. And now I've put it into slope-intercept form, which is y equals mx plus b. And now that it's in slope-intercept form, I can identify the slope as the coefficient of the x. The slope of the line is how much the line is tilted. And I can identify the y-intercept, and the y-intercept is 2. So the ordered pair 0, 2 will be on the graph. So with this information, I'm going to draw the graph. So let me get my coordinate plane. And I am going to graph the circle first. So the circle has a center of 0, 0 with a radius of 3. Let me move this over just a little bit so you can see that radius. There's a center of 0, 0 with a radius of 3. And that means that if I go 3 to the right of that center, we have a point on the circle. 3 above that center, we have a point on the circle. 3 to the left is a point on the circle, and 3 down, there's a point on the circle. So we can connect those 4 points, and we have a sketch of our circle. And we also want to graph the straight line, and the straight line has a y-intercept of 0, 2, and a slope of negative 1. For the slope, we're going to treat negative 1 as negative 1 over 1. And when it's in fraction form, we can treat that as rise over run. The slope is rise over run. That's how much the line is tilted. So I'm going to rise negative 1, go down 1, and to the right 1. And that gets me a second point on the line. I connect those 2 points with a straight line. And I'm taking a look at the intersection points. The line and the circle intersect in 2 places, so this system will have 2 solutions. We can see the approximate value of those solutions, although it's not easy to come up with the exact answer graphically. We do get an estimate. So looking at the x-coordinate is in between 2 and 3, closer to 3. So let's say 2.9. And the y-coordinate is in between 0 and negative 1. So let's say negative 0.5. Remember, this is just an approximation. It's not the exact answer. For the other intersection point, in between negative 1 and 0, so let's say negative 0.5, and for the y-coordinate in between 2 and 3, let's say 2.5. So sketching a graph tells us how many solutions and the approximate value of those solutions. But if you want to find the exact solution, you're going to solve it algebraically using the substitution or elimination method. Determine the real solutions to the system of nonlinear equations. Our system is x plus y equals 2 and y equals x squared minus 4. So now we want to solve this system. First, I want to do a very quick sketch of the graph. I'm not going to do the sketch in detail. This is just to give me an idea of how many solutions I might have. So the first equation is a linear equation, and the graph will be a straight line. The second equation is a quadratic equation, and a quadratic equation will have a graph of a parabola. So if I were to draw a parabola and a line in the same coordinate plane, if they were right on top of each other, we might get two intersection points, and that would mean two solutions for the system. However, if they were a little bit further apart, you could have the line being tangent to the curve, meaning that the line only touches that parabola in one point. So one intersection point means one solution. Or if they were even further apart, they would not have any intersection points and the system would have no solution. So when we solve this system, we might get two solutions, we might get one solution, or we might get no solution. So let's solve the system, and there are two methods that I typically use for solving systems, and that is the substitution and the elimination method. So I'm going to try both methods so you can see both techniques. So let's start with the substitution method. So with the substitution method, you want to solve for one of the variables in either equation. So when I look at this second equation, I can see that I already have y solved for, so that first step is already done. Then comes the substitution. You're going to substitute that into the other equation. If you substitute into the other equation, you'll get a new equation, x plus x squared minus 4 equals 2. Let's rearrange x squared plus x minus 4. I rearranged in descending order. And I'm going to subtract 2. And that gives x squared plus x minus 6 equals 0. So now I have an equation with only one variable, and I should be able to solve that equation. I can solve by factoring. X times x is x squared. 6 is 2 times 3. And that's a negative 6, so I know one of those numbers is going to be negative. Then I look to the middle term, which is a 1. It's a positive 1, so I want my larger number to be positive. Got negative 2 plus positive 3 is going to give me the positive 1 in the middle. And negative 2 times positive 6 gives me the negative 6 at the end. So now I've got it completely factored, and I'll set each factor equal to 0. This is using the zero product property. X minus 2 equals 0. We'll solve to be x equals 2. X plus 3 equals 0. We'll solve to be x equals negative 3. Now, if you'll recall, my solutions are going to be these intersection points. These intersection points are ordered pairs, and they're going to have both an x and a y. So even though we have two numbers here, these are both x's. So we need to find the y. I'm going to take these x's and substitute it back into either one of these equations, and that will give you the y coordinate. So using y equals x squared minus 4, y is 2 squared minus 4. 2 squared is 2 squared is 4, minus 4 is 0. So that gives one of our solutions to be the ordered pair 2, 0. The other solution would be y equals negative 3 squared minus 4. Negative 3 squared is 9, minus 4 is 5. So the other solution is negative 3, 5. So we found our solutions to the system using the substitution method to be 2, 0 and negative 3, 5. So now I'll show you the same system with the elimination technique. Now with the elimination technique, you want to add the equations together. But in order to add the equations together, you need to have all of your like terms lined up. Your x's, your y's, most importantly, your equal sign, and your constants. So right now, my equal sign is not lined up. My like terms are on my, like my variables are on different sides. So I want to rearrange the equations so that my x's and y's are on the left and my constant is on the right. So I'm going to take that second equation and I'm going to subtract x squared on both sides. And this is going to give me my x's and y's on the left, negative x squared plus y, and my constant on the right equals -4. So here's what the system looks like now. X plus y equals 2, and negative x squared plus y equals -4. So now I have my x's lined up, my y's lined up, equal sign lined up, and constants lined up. So we need to have it in this state before we start the elimination method. Now we're going to figure out which variable to eliminate. You can only eliminate variables that have like terms. The x and the x squared, even though they're the same variable, they're not like terms, so we cannot eliminate x. We have y and y, those are like terms, and we'll be able to eliminate the y. We need the y to have the same coefficient and the opposite sign. Right now they have the same coefficient, but not the opposite sign. So I'm going to multiply a -1 onto the equation. Either one. I'm doing it to the second equation, and now my new system is x plus y equals 2, x squared minus y equals a +4. So now we have the y terms with the same coefficient and the opposite sign. Now I'm ready to add the equations together. And when I add the equations together, one of the variables will eliminate. So I add the equations together, I get x squared plus x. Add the equations together, y minus y gives me 0, so y is the variable that eliminates. So here's what I have, x squared plus x. The y's eliminate, and on the other side, 2 plus 4 equals 6. This gives me a quadratic equation. I'll move all the terms to the same side, get x squared plus x minus 6 equals 0. And I'll factor this quadratic equation. Just like before, you can see it's the same quadratic equation as before. We have x times x gives me x squared. 2 times 3 gives me 6. Need a plus on the 3 and a minus on the 2. So this factors to be x minus 2 times x plus 3 equals 0. And I'm going to set each factor equal to 0. X minus 2 equals 0. X plus 3 equals 0. We get x equals 2. X equals -3. We're going to substitute back in. This time, let's use the other equation. Okay, so I'll use this equation to substitute back into. We have x plus y equals 2. So 2 plus y equals 2. If I subtract 2, that gives y equals 0. So one of my solutions is 2, 0. Let's do the same thing for the other one. If x plus y equals 2, -3 plus y equals 2, I'm going to add 3 to both sides, and y equals 5. So that gives our second solution being -3, 5. These are the same solutions that we got with the other method. I'm just going to zoom out so you can see the whole problem again. So we've got our solutions to the system being 2, 0, and -3, 5. On this question, we want to determine the real solutions to the system of nonlinear equations. Our system is x squared plus y squared equals 225, and x minus y equals -3. We're going to solve this system using either substitution or elimination. And as I look at this example, it looks like we won't be able to use the elimination method, only the substitution method. So I'll explain why in just a few moments. But before we get started, I like to draw a quick sketch of each equation to get an idea of how many solutions I expect to get. That first equation is x squared plus y squared equals 225. This is the equation of a circle. The second equation is a linear equation, x minus y equals -3. And the linear equation will have a graph of a straight line. So if we draw a circle and a straight line right on top of each other, you can have two intersection points, which would mean two solutions to the system. If you take them a little bit further apart, we get something like this. This is where the line is tangent to the circle. The line touches the circle in one place. So we would have one intersection point, one solution. Or you could have them further apart where they're not touching each other. In that case, you would have no solution to the system. So as we solve this system, we're expecting to have either two solutions, one solution, or no solution. So with the substitution method, you want to solve for one of the variables in either equation. So I'm going to take the simpler equation, which is x minus y equals -3, and I'm going to solve for x by adding y on both sides. That gives x equals y minus 3. Once you've solved for one of the variables, you're going to substitute that into the other equation. And that will give us y minus 3 squared plus y squared equals 225. So now I have an equation with only one variable. So let's try to solve it. So y minus 3 squared is y minus 3 times y minus 3 plus y squared equals 225. Let's multiply that out. Y times y is y squared. Y times -3 is minus 3y. -3 times y is -3y. -3 times -3 is 9. Carry down that, y squared equals 225. Now let's combine like terms. We have y squared plus y squared. That's 2y squared. We have minus 3y and minus 3y. That's a minus 6y. And the plus 9. So let's collect all the terms to the same side. I'm going to subtract 225. And positive 9 minus 225 is 216. So we have 2y squared minus 6y minus 216 equals 0. So let's try to factor this. 2, 6, and 216 are all even numbers, so I can factor a 2 out. That leaves me with y squared minus 3y minus, let's see, minus 72 equals 0. And I'm going to try to factor. In order to factor this trinomial, I need to know the factors of 72. It's a bigger number, so I'm not as familiar with those factors. So let's write them down over here on the left. 72 is 1 times 72. 2 times 36 is 72. 3 times 24 is 72. 4 times 18. 5 doesn't go in there. 6 does. 6 times 12. 7 doesn't go in there. How about 8? 8 does. 8 times 9. And I think that is the end. That's all of our factors. And when we're looking at our factors, you're trying to see if you're trying to get the right middle number. So we need a -3. So we need there to be a difference of 3 between these numbers, and none of these have a difference of 3. So that means that we're not going to be able to factor. We have to use a quadratic formula to solve this. So with the quadratic formula, we identify A as 1, B as -3, and C as -72. And we're going to plug into the quadratic formula. The quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So x equals -3 plus or minus the square root of -3 squared minus 4 times a is 1, times c, that's -72, all over 2 times 1. So we'll simplify. -3, that's a +3, plus or minus the square root. -3 squared is 9. A negative times a negative will be a positive, and we need to know what 72 times 4 is. That's 288. 9 plus 288 is 297. So we've got 3 plus or minus square root of 297 over 2. Okay, that's as our y coordinate. And this is getting pretty messy, so I'm going to double check to make sure that I didn't make a mistake here before I go any further. So let's just walk through this process. I added y to both sides and got y minus 3. And I plugged in here and got y minus 3 squared plus y squared equals 225. Multiplied out. Okay, that looks good. Combine like terms. That looks good. Let me double check. 225 minus 9 is 216. Divide that by 2. Okay, so here is where my mistake was. Okay, so 216 divided by 2 is not 72. I'm not sure where I got that number from. So let's correct this. Okay, so I'm gonna scrap all this and scrap all this. And let's make that correction. So I've got 2y squared minus 6y minus 216 equals 0. And I'm factoring out a 2. That leaves me with y squared minus 3y minus 108. So 216 divided by 2 is 108. Okay, so now let's look at factors of 108. 1 times 108, 2 times 54. 3 does go in there. That's 36. 3 times 36. Let's see, does 4 go in there evenly? It does. 27. 5 doesn't. 6 does. 6 times 18 would give me 108. And let's see, 7 doesn't. 8 doesn't. 9 does. 9 times 12. And that's the one that I was looking for. 9 times 12 will give me a difference of 3. So now I can factor this. 2 times y. Y times y gives me the y squared. 12 and 9 multiply to be the 108. I need the negative on the 12 and the positive on the 9. So we've got that factor to be 2 times y minus 12 times y plus 9 equals 0. We set each factor equal to 0. We have y minus 12 equals 0 and y plus 4 equals 0. We have y equals 12 and y equals negative 9. We're going to substitute this back in right here so we can get the x coordinates. We have x equals 12 minus 3, that's 9. So one solution is 12, 9. X equals negative 9 minus 3, that's negative 12. So the other solution is negative 12, negative 9. We have our solutions. And earlier I mentioned that we couldn't use the elimination method. And that's because we don't have like terms. Our x's are not like terms and our y's are not like terms. So we can't use that elimination method in this example. Determine the real solutions to the system of nonlinear equations. Here we have y equals x squared plus 4x plus 3, and y equals negative x squared plus 16x minus 13. Now when we solve systems like this, we typically use substitution and elimination, or either one of those methods. In this example, it looks like we might be able to use elimination because we have the y terms being like terms. So we could use the elimination method. We could also use the substitution method because we have y equals. So I'll show you both methods. Before we show those two methods, I want to do a quick sketch. So we have the first equation being a quadratic equation, and the graph of a quadratic equation is a parabola. And this is an up-facing parabola because our leading coefficient is positive. The second equation is also a quadratic, and this time we have a parabola that faces down because our leading coefficient is negative. So if we were to draw two parabolas, an up-facing and a down-facing parabola on top of each other, we could get two intersection points, meaning two solutions. We could draw the parabolas a little bit further apart and have one solution, one intersection point. Or you could have them farther apart. In that case, you would have no intersection points and no solution to the system. So with this system, we are expecting to get either two solutions, one solution, or no solution. Now let's see how we would solve this with the substitution method. Now, if we solve it with the substitution method, we have already one variable solved for, and we can substitute into the other. When we substitute into the other, we would get the equation x squared plus 4x plus 3 equals negative x squared plus 16x minus 13. Now our equation only has the variable x, and I'm going to move all the terms to the same side. So let's add x squared, subtract 16x, and add 13. Okay, this is going to give 2x squared minus 12x plus 16 equals 0. I'm going to try to factor this quadratic by factoring out the greatest common factor first. So I can factor 2 out. That would be x squared minus 6x plus 8 equals 0. Then I'm going to try to factor more. I have x times x is x squared. 4 times 2 gives me 8. Both of them negative will make us have the right middle term and last term. Negative 4 times negative 2 is a positive 8. Negative 4 plus negative 2 will give us the middle term, negative 6. So now we have it factored, and we're going to set each factor equal to 0. X minus 4 equals 0. X minus 2 equals 0. We solve and get x equals 4 and x equals 2. So this gives us our x coordinates, and we're going to substitute in to get our y coordinates. So if x is equal to 4, y is 4 squared plus 4 times 4 plus 3. 4 squared is 16. 4 times 4 is 16 plus 3. So 16 plus 16 would be 32 plus 3. That's 35. And if x is equal to 2, y is 2 squared plus 4 times 2 plus 3. It's 4 plus 8 plus 3. 12 plus 3 is 15. So we have solutions of 4, 35, and 2, 15. So this is solving it with the substitution method. Now let's try again using the elimination method. Let's see what that would look like. I'm going to rewrite the system here. We have y equals x squared plus 4x plus 3, and y equals negative x squared plus 16x minus 13. Now, if we were going to use the elimination method, you've got to have like terms. We have the y's being like terms. We also have the x's being like terms here as well, but because you have x squareds and x's, we would need for both of them to eliminate at the same time. And we can't do that with these different coefficients. So we need to eliminate the y term. So I need the y terms to have the same coefficient with the opposite sign. Right now they have the same coefficient. I'm going to multiply by -1 to get the opposite sign. So this gives me the system y equals x squared plus 4x plus 3, and negative y equals x squared minus 16x plus 13. So then we will add the equations together. Y minus y gives me 0 on the left. X squared plus x squared is 2x squared. 4x minus 16x is a negative 12x. And 3 plus 13 is 16. Now you'll notice this is the exact same equation that we got earlier. 2x squared minus 12x plus 16 equals 0. So if we have the exact same equation, we're going to get the same solutions. And when we substitute back in, we're going to get the exact same y coordinates. So this gives us, with the elimination method, the same solutions that we had before, 435 and 215. Let me zoom out so you can see the whole problem. Determine the real solutions for the system of nonlinear equations. This equation is y squared equals x squared minus 9, and 2y equals x plus 3. We're going to try solving this system. Before we solve it, let's draw a sketch of the graph. And the first equation looks kind of similar to a circle, but it doesn't fit the format exactly. It's actually a different type of equation. It's not a circle. It's something called a hyperbola. We don't really study those in this college algebra class, but a hyperbola is sort of like two parabolas that face away from each other. And they can go horizontally like this or vertically. If you move on to pre-calculus, we do have a chapter on this. It's called the conic sections chapter. So this is a hyperbola. The second equation, 2y equals x plus 3. This is going to be a linear equation. The graph will be a straight line. So if we were to draw a hyperbola and a line, there are many different ways you can draw it. You could draw it like this. We get two intersection points that way. You could draw the hyperbola and the line at an angle. And there is an angle here that you can draw it on where you have no solution. And so this is two solutions, and you can draw the line so that it is tangent to the hyperbola. And that would be just one solution. Okay, there might be other ways to draw it, but these are the ones that come to mind initially. So we could have two solutions, one solution, or no solution for this type of system. Now let's think about how we're going to solve this. Now if I look at the y terms, I have y squared and y. Those are not like terms. I cannot eliminate y. X squared and x, those are not like terms. I cannot eliminate x. So let's try this with the substitution method. So I'm going to take the second equation and I'm going to solve for x because it doesn't have a coefficient. That means I won't have to worry about the fraction. So 2y equals x plus 3. I'll subtract 3. That's x equals 2y minus 3. We're going to substitute that into the other equation. That's going to give y squared equals 2y minus 3 squared minus 9. So y squared equals, let's multiply, 2y minus 3 times 2y minus 3 minus 9. That's y squared equals 4y squared minus 6y plus 9 minus 9. And we get y squared equals 4y squared minus 12y. We're combining like terms. And let's move all the terms to the same side. So if we move all those terms to the same side, I'll subtract y squared. And that gives the equation 0 equals 3y squared minus 12y. I can factor out the greatest common factor. That's 3y. If I factor out a 3y, I'm left with y minus 4. I'll set each of these factors equal to 0. 3y equals 0 and y minus 4 equals 0. That gives y equals 0 and y equals 4. We'll substitute those y's back in, and that will give x equal 2 times 0 minus 3, that's negative 3. So one solution is negative 3, 0. And x equals 2 times 4 minus 3, that's 8 minus 3, which is 5. We get 5, 4 for the other solution. So that gives us our two solutions to the system. And I'm going to take a couple minutes as I was talking about using the elimination method. I thought maybe there is a way I could use it. I think it's a little bit messy and I don't think you would want to use it this way, but I'm going to try to see if it works. So let's rewrite this system again. And that system is y squared equals x squared minus 9 and 2y equals x plus 3. So I said earlier that I couldn't use the elimination method because these were not like terms. So what if I make them like terms by squaring both sides? So let's try that. So the first equation I'll leave as y squared equals x squared minus 9. the second equation, if I square the left, it will give me 4y squared, and if I square the right, I'll have x plus 3 squared. So let's simplify that second equation. We have 4y squared equals x plus 3 times x plus 3. That's x squared plus 3x plus 3x plus 9. That's x squared plus 6x plus 9. Okay, so my new system would be y squared equals x squared minus 9, and 4y squared equals x squared plus 6x plus 9. So I can try the elimination method now that my y terms are like terms. I'm going to multiply by a negative 4 to the first equation so that I can have the same coefficient with the opposite signs, and that will give the system negative 4y squared equals negative 4x squared plus 36. The second equation is staying the same. Now I can add the equations together. The y variable eliminates. Negative 4y squared plus y squared is 0. Negative 4x squared plus x squared is 3x squared. Then I have a 6x, and 36 plus 9 would be 45. I'm going to try to solve this quadratic equation. I can factor out a 3. That's x squared plus 2x plus 15. Let's try to factor that quadratic. X times x is x squared. 15 is 5 times 3. And I need to get a 2 in the middle. And I've made a mistake here, I apologize. Negative 4x plus 1x, negative 4x squared plus 1x squared should be a negative 3. I'm going to factor out a negative here, and that's going to make these negative. So that means I can factor, and I would need a negative 5 and a positive 3. So now I'll set each factor equal to 0, and I get x equals 5 and x equals negative 3. Let's just take a quick look. And you'll see that previously we got the x coordinate to be negative 3 and 5, so it's looking good. Now let's find the y coordinate. Let's find the y coordinate by plugging in to here. So this gives y squared equals x squared minus 9. Y squared is 5 squared minus 9. Y squared is 25 minus 9. And 25 minus 9 is 16. Y squared is 16. I can square root both sides. That gives y equals plus or minus 4. So that's 2 ordered pairs. That is an x of 5 and a y of 4, an x of 5 and a y of negative 4. Okay, how about if x is equal to negative 3? Y squared is negative 3 squared minus 9. Negative 3 squared is 9. 9 minus 9 is 0, so we get y squared equals 0, so y is 0. That gives the ordered pair negative 3, 0, just like we got before. I have this extra solution here. Let's see if this extra solution works in the second equation. I know it works in the first equation because that's where it came from. So in the second equation, 2 times negative 4 equals 5 plus 3. That's negative 8 equals 8, and that's false. So this extra or extraneous solution does not work in the second equation, so we have to exclude that. Now that could have happened in the first example as well. That could have happened in the substitution method if I would have substituted into the first equation instead of the second equation. So this extraneous solution might have happened either way we did it. So we have to be careful when we have those squareds. So the solutions to this system are 5, 4, and negative 3, 0. Thank you for checking out my videos. Have a great day.